Yeah, fine. Thank you so much. So you're in grade 8, right?
Yes.
Okay. So we'll be having a small topic with grade 8 portions. So are you familiar with surface area?
Surface area.
Yeah,
Uh,
no problem. In case if you do not know, you're going to learn it. Okay.
okay.
So you'll be having a topic called surface area and mensuration in grade 8. Okay. So you'll be learning it. So we are going to look into that particular concept now. Okay. So before moving on with like surface area, you know what area is? Normal area that we come across area perimeter.
Yeah.
So what area is? Like what an area is or what a perimeter is.
Area
Yeah.
is the space space that it takes up, like of the shape.
Very good. So area is nothing but the space occupied by the shape. Okay. What do you mean by perimeter then?
The border of the shape.
Very good. So you call it as a boundary or the border for that particular shape, right? So these are the two terms that you've been learning already. Like you've been familiar with these two terms. So area in simple, if I say like what an area, what a perimeter is. If I take the object, sorry, the shape rectangle, this inner lines that I'm drawing, okay, these lines which occupies or which completely covers that figure, you call it as the area. So the space inside the shape, you call it as area. Instead, if I'm going to talk about like this particular boundary, right, the outer line, I call this purple color outer line as a perimeter, which means the outer covering or the boundary, we call it as perimeter. So you're clear with this, right? Like what an area
Yeah.
is, what a perimeter is. Very good. Did you learn about three-dimensional shapes? You would have learned in sixth and seventh, right?
Yeah.
3D figure. So when we have an object with a third dimension, which is called the height, it is no more a shape, it becomes an object. So that object is nothing but our real life examples that we are using, your containers, your water bottles, yeah, the rubrics book that you have. Like, so all these like 3D shapes are called solids. So when we are talking about the area of solids, then comes into picture, which is called surface area. So when you are talking about the area of solids, you call it as surface area. Okay. So all these time like a two-dimensional figure, a 2D shape, you are very much comfortable. You know what area is, what perimeter is. In case if we have a three-dimensional solid, like a container, a water bottle, what do we call the area of that particular solid? We call it as surface area. Okay. So how are we going to find out the surface area of a cuboid? That is the first thing that we are going to work out today. You know what a cuboid is?
Yeah.
Yeah, what a cuboid is?
A cuboid is like uh, a 3D rectangle.
Yeah. So can I say that if I have a rectangle, so I have one rectangle here and I have another rectangle here. So when I give a three-dimensional effect for this particular rectangle, can I say this is cuboid?
Yes.
Yes. So the three-dimensional figure is called as a cuboid, right? So when I have a cuboid, like for example, let me show it in different colors so that it will be useful for you. Okay, so let me draw first one rectangle in purple color. And I I draw another rectangle in another different color so that it will be easy for you to like find out. Okay, I'm taking a red color now. Okay. Now, this is going to be a cuboid, right? How many rectangles to this cuboid is like made of? To make a cuboid, how many rectangles do we need?
4
Is it only four? Just
on
imagine
this
you'll
side.
have one, yeah, this cuboid box. So one in the front, one at the back, two at the sides, and do you have one at top and one at bottom?
Yeah,
Imagine a cuboid box. So how many rectangles are there totally?
6.
Exactly. So we have six rectangles together to make a particular cuboid, right? To make a cuboid, we have six rectangles. So surface area is nothing but sum of areas of all the shapes that solid has. So here, the solid we are looking into is a cuboid. It has six rectangles in it. So when we add up the area of all the six rectangles, we get the area of that solid. Okay. Now let us see how do we add it up. Now, as I told, it is a three-dimensional figure. So the cuboid box will have the length, the cuboid box will have the breadth, and the box will also have the height. So now we are going to find out the area of this particular box. As I told, I'm going to add all the areas of the rectangles. So you told there are six rectangles first, right? Now let me take the rectangle which is at the front. So what will be the area of rectangle formula?
Length into breadth into height.
Area of a rectangle. Rectangle will not have a height,
Oh,
right?
okay, yeah, length into breadth.
Yeah. So the normal area of a rectangle is length into breadth. Now look at rectangle 1. It has a length. Just leave out everything. Go with the rectangle 1 alone, this particular rectangle. So it has a length and it also has a height as the sides. Yeah. So it has length and side. So what I'm doing, I'm writing the area of the first rectangle to be L into H. Now, find out the area of the second rectangle. Second rectangle is, I'm taking the rectangle which is exactly at the opposite side, which is at the back side of the first rectangle. So, even that rectangle has length and height. So, the area will be length into height. Now, two rectangles are over. I'm going to go with the third rectangle. Now, third rectangle, I'm taking this side rectangle. So this is my third rectangle. Here, if I look at the rectangle, the sides are breadth and height. So B into H plus I'm taking the exact opposite of that rectangle as my fourth one. So the fourth one will also have B into H. That is breadth into height. Plus, I'm going to go with my fifth rectangle. I'm going to take the top one as my fifth rectangle now. The top one has length and it has the breadth. So L into B. Plus the last rectangle is my rectangle at the bottom. It also has length and breadth. So L into B. So you're clear like what I'm doing? I'm just finding out the area of all the six rectangles. Do you have any doubt in this?
No.
Okay. Now comes the simplification part. So how can we write L into H in normally in algebraic form? Can I write it as LH?
No.
Why no? What in algebra, like terms or unlike terms, you know that multiplication doesn't need to be put in between the two variables. If I have L into H, I can simply write it as LH, which means LH also says that I am multiplying L into H. This multiplication can be silent according to algebraic expressions. Okay. So LH plus LH, B into H is nothing but BH, B into H is nothing but BH. Then I have LB plus LB. So when I am in algebra multiplication, the multiplication sign can also be silent where I need not put that. Okay. So this LH simply means that I'm multiplying L and H. Okay. Now when I look at my simplified form, again I could see that I have 1 LH plus 1 LH, which is nothing but 2 LH. So plus 1 BH, 1 BH here, which means it is 2 BH, 1 LB and 1 LB here, which means it is 2 LB. So now I could see that 2 is common on all of my three terms. So I'm taking that common. I have 2 into LH plus BH plus LB as my formula for this particular surface area of a cuboid. So we have just derived the formula like how to find out surface area of a cuboid. So if they ask you to find out surface area of a cuboid, what is the formula? The formula is 2 times multiplication of LH plus BH plus LB. So L, B and H are their length, breadth and height. So adding everything, multiplying with 2 will give us the total surface area of that particular cuboid. Are you clear?
Yeah.
So what we have done all this time is we've derived the formula. So we need not mug up the formula now. You know how the formula has come. It is just addition of all the 6 spaces. So even in case if you forget your formula during exams, you need not worry about it. You're just adding the area of all the 6 rectangles that will give you the answer. Got it?
Yeah.
Yeah. So you put your